Arc fault circuit interrupters, known as AFCIs, are specifically engineered to identify electrical arcs. Arcs are indicative of a hazardous condition, potentially leading to electrical fires. The primary function of an AFCI is to monitor the electrical circuit for these telltale arc patterns and, upon detection, to interrupt the circuit, thereby mitigating the risk of fire. When a fan coil unit is incorporated into a circuit protected by an AFCI, the possibility exists that the AFCI may trip when the motor within the fan coil unit is initially energized. The reason for this lies in the nature of motor starting currents. When a motor first starts, it draws a substantially higher amount of current compared to its steady-state running current. This elevated current draw can, under certain circumstances, generate an electrical arc. The AFCI, designed to be highly sensitive to such anomalies, may interpret this inrush of current as a dangerous arc fault and activate its protective tripping mechanism. If the magnitude of the motor starting current surpasses the predetermined sensitivity threshold of the AFCI will indeed trip, effectively disconnecting the circuit to safeguard against potential electrical hazards. It is important to acknowledge that the sensitivity of AFCIs can vary across different models and manufacturers. Some AFCIs are inherently more susceptible to tripping in response to motor starting currents than others. This variability is due to differences in the internal circuitry and the algorithms used to detect arc faults. Therefore, the likelihood of an AFCI tripping when a fan coil unit motor starts is not a certainty, but rather a possibility dependent on the specific characteristics of both the AFCI and the motor. To mitigate the occurrence of nuisance tripping of AFCIs due to motor starting currents, it is advisable to employ AFCIs that are specifically designed and rated for use in conjunction with motors. These specialized AFCIs are engineered with higher sensitivity thresholds that are calibrated to tolerate the transient inrush currents associated with motor starting. By raising the threshold, the AFCI is less likely to misinterpret the motor starting current as a genuine arc fault, thereby preventing unwanted tripping. In situations where the applicable electrical code, such as Article 210.12 of the National Electrical Code, does not mandate the use of AFCI protection for the specific circuit in question, an alternative approach is to connect the fan coil unit to a circuit that is not equipped with AFCI protection. This approach circumvents the potential for nuisance tripping caused by the motor starting current interacting with the AFCI sensitivity. However, it is paramount to ensure that this decision is made in strict accordance with the prevailing electrical codes and regulations to maintain electrical safety and compliance. Now, let's delve into the technical aspects of arc fault circuit interrupters and their interaction with motor loads, particularly in the context of fan coil units. An AFCI's primary function is to detect and respond to unintended electrical arcs, which can be a precursor to electrical fires. These arcs can occur due to various factors, including damaged wiring, loose connections, or insulation breakdown. The AFCI employs sophisticated electronic circuitry to distinguish between normal operating arcs, such as those produced by switches and brushed motors, and potentially hazardous arc faults. There are primarily two types of AFCIs: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs are designed to detect parallel arcs, which occur between phase conductors or between a phase conductor and a neutral conductor. Combination AFCIs, on the other hand, are designed to detect both parallel arcs and series arcs, which occur in a single conductor. Series arcs are often more difficult to detect than parallel arcs, making combination AFCIs the preferred choice for comprehensive arc fault protection. When a fan coil unit is connected to an AFCI-protected circuit, the motor within the fan coil unit becomes a potential source of nuisance tripping. As previously mentioned, motors draw a significantly higher current during startup compared to their normal running current. This inrush current can create a transient voltage drop in the circuit, which can, in turn, generate a brief electrical arc. The AFCI may interpret this arc as a hazardous condition and trip the circuit, even though it is a normal part of motor operation. Several factors can influence the likelihood of an AFCI tripping due to a fan coil unit motor. Firstly, the size and type of the motor play a crucial role. Larger motors typically draw higher starting currents, increasing the risk of tripping. Secondly, the impedance of the circuit wiring can affect the magnitude of the voltage drop during startup. Higher impedance wiring will result in a larger voltage drop, potentially exacerbating the arc. Thirdly, the sensitivity of the AFCI itself is a critical factor. AFCIs from different manufacturers and even different models from the same manufacturer can have varying sensitivity levels. To mitigate the risk of nuisance tripping, it is essential to select an AFCI that is specifically designed for use with motor loads. These AFCIs typically have a higher tolerance for transient voltage drops and are less likely to trip on normal motor starting currents. Additionally, it is crucial to ensure that the circuit wiring is properly sized and installed to minimize impedance and voltage drop. Article 210.12 of the National Electrical Code outlines the requirements for AFCI protection in dwelling units. The specific requirements may vary depending on the edition of the NEC and the local jurisdiction. Generally, AFCI protection is required for branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. If the fan coil unit is installed in one of these locations, it will typically require AFCI protection. However, there may be exceptions to this requirement. For example, some jurisdictions may allow the use of a non-AFCI circuit for a dedicated motor circuit if certain conditions are met. It is essential to consult the local electrical code and the authority having jurisdiction to determine the specific requirements for AFCI protection in a given application. If it is determined that AFCI protection is required for the fan coil unit circuit and nuisance tripping is occurring, there are several steps that can be taken to address the issue. Firstly, ensure that the AFCI is properly installed and wired. Incorrect wiring can cause the AFCI to malfunction and trip unnecessarily. Secondly, verify that the circuit wiring is adequately sized for the motor load. Undersized wiring can contribute to voltage drop and increase the likelihood of tripping. Thirdly, consider replacing the AFCI with a model that is specifically designed for motor loads. These AFCIs typically have a higher tolerance for transient voltage drops and are less likely to trip on normal motor starting currents. Fourthly, explore the possibility of using a motor starter with reduced voltage starting. Reduced voltage starting techniques such as auto-transformer starting or power winding starting can significantly reduce the inrush current during motor startup, minimizing the risk of AFCI tripping. Fifthly, if all other measures fail and it is permissible under the local electrical code, consider installing a dedicated circuit for the fan coil unit without AFCI protection. This option should only be considered as a last resort and after consulting with a qualified electrician and the authority having jurisdiction. In addition to the above, it is important to note that some AFCIs may be more prone to nuisance tripping than others due to manufacturing defects or design flaws. If you suspect that your AFCI is defective, contact the manufacturer for assistance. They may be able to provide a replacement AFCI or offer guidance on troubleshooting the issue. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, it is always best to consult with a qualified electrician. They can safely and effectively diagnose and resolve any electrical issues you may be experiencing. In summary, the interaction between fan coil units and AFCIs can be complex, and nuisance tripping can occur due to motor starting currents. To mitigate this risk, it is essential to select an AFCI that is specifically designed for motor loads, ensure that the circuit wiring is properly sized and installed, and consult with a qualified electrician if you are experiencing persistent problems. It's also worthwhile to investigate whether the fan coil unit is truly required to be on an AFCI circuit in the first place, as per the latest edition of Article 210.12 of the National Electrical Code. If it is not a requirement, installing it on a standard circuit breaker might solve the problem while remaining code compliant. Remember to always prioritize safety and consult with qualified professionals when dealing with electrical systems.